Hello, good morning, everyone. Thanks for joining my talk about a personal story with the title, A More Secure Home Starts with a Safer Base Image. So I guess you're wondering what all of this has to do with platform engineering and why you're here. I hope this will be more visible during the talk. So first of all, let me give you a quick introduction. Who am I? My name is Christoph. I'm working for a company called Chainguard. We're going to buy you guys the beer this evening. Yeah, thank you. And in my private life, I like tinkering. I like tinkering a lot. So I'm super into things like home automation. I like soldering little pieces together. I like to actually make my home as automated as possible, so my home knows where I am, and my home does things when I'm not at home, which it doesn't do when I'm at home. If you want to chat a bit more about home automation, please find me at the booth. I'm happy to show you everything I can. Yeah, my home automation obviously is based on open source. I also like 3D printing a lot, and for 3D printing, I'm using an open hardware project called Voron, which is where you buy 140 packages off of AliExpress. You got instructions how to assemble it. My wife hates me because like every day DHL, DPD, Hermes, and all of the others are ringing at my doorbell and bringing me stuff. On top of my 3D printers, obviously there's also software running, which is called Clipper. Anybody knows this? Perfect. Which, of course, is also open source software. This has nothing to do, actually, with the main topic of this talk, but I just wanted to tell you. I also have some giveaways, so the first 2 people who can tell me what these numbers are, they're going to get a prize. Please visit me at the booth, tell me what this is. Nothing to do with my talk, just to give something away. All right, in my professional life, I'm working with Kubernetes a lot for the last, I think, roughly 10 years now already. That started back when I was with VMware and we had this NSX integration for Kubernetes. Since I joined Chainguard, I'm actually working a lot more with bare bones container images, and I'm taking CVEs in those container images much more seriously than I did ever before, right? Anybody of you taking care of CVEs in your deployment pipelines, container images? Like roughly 50%. All right, maybe the other 50% will do as well after this talk. Let's see. That's my goal for today. All right, so this brings us to the why we are here. If we're not talking about 3D printing and home automation, like whatever I'm showing you next and what I'm going to demo, you can apply the same things to essentially all of your applications that you're running at home or in your companies. Coming back to home automation. For my home automation at home, I'm, again, I said, relying on an open source project, which is called Home Assistant. Anybody ever heard of Home Assistant? Oh, cool, perfect. Just one thing, I'm not blaming the Home Assistant team for what I'm showing later on. They are doing a great job. It's one of my most favorite open source projects, using it for 6 years now, I think. But I just want to show you the importance of actually looking at what you're building your application on top of. Right? Today, for those of you who don't know Home Assistant, check it out. Can highly recommend it. It's super great. So Home Assistant runs in Docker, at least in my installation. You can run it differently, but mine's running in Docker. And as it's open source software, there's this one thing about open source that everybody, especially these days with all the frontier models like Mythos and things like that, struggles with. Like open source accumulates CVEs over time, right? The code is openly visible for everyone. It's shipped with the best intentions in mind, but after a given amount of time, people will find weaknesses in this code base, right? Which are then made publicly available, they're patched, and yeah, you should get rid of them, essentially. So I thought, I'm running my home on an open source project, and this has the credentials to pretty much everything. It can open my doors, it can open my shutters, it has the API keys for my lights. So should I look into this? Maybe. Is this good or is it not good? Am I paranoid? And this is essentially the start of our exercise today, where we're going to look a bit into how this specific software is built, but you can, as said, apply it to whatever software where you want to apply this to. All right, so first of all, let me show you that I actually have something working with me. So you see, my Home Assistant is running. Here's my logs. I have a light, which blinks here. So it's actually a working installation. I'm not faking anything here. Right. All right, I think I need this one, yeah. So it's running as a Docker container, and it's the official latest image, which was built, I think, end of last week. And I want to show you how it's actually being built. Like the Home Assistant project itself, they have several projects, and they're building a golden image, which they are then using to build each of the other projects on top of. Right, so if we have a look how this was built, is this big enough? Yes, some say yes, some say no, make it slightly bigger. Essentially, this is built on their golden image, which was last built in May, right? Quite a while ago. We talked about CVEs, they accumulate. So if you don't rebuild, you're gonna end up with an image with a few CVEs in there. On top of this, they are then building essentially the actual Home Assistant application. Well, this is the golden image, which is built on Alpine 323 as a very base image. So let's dig a little bit into if there are vulnerabilities in there, if it's a good idea to run this software at home, giving access to everything at home. So we're starting with a very base image, which is Alpine. Alpine itself, you can see, if I'm running a gripe CVE scan over the base image, it has 3 vulnerabilities, which is a relatively good starting point for a base image. But what you'll also see later is that it's not necessarily about the base image, it's also about the dependencies that you're pulling into this base image and how they are built and where they're coming from. Right, so we know we have a pretty solid base image that's being used for this specific application. As just an example, anybody wants to take a wild guess how many CVEs are in an image that was built last week? 200, anyone more? 300. I think if you take 200 plus 300, you're roughly at the number that's going to show up in a bit. It takes quite a while because we'll also see later that like the image itself is super, super big. It should do something. Yeah, let's go. It does something. And we can see numbers are starting to count. Numbers are starting to count, counting. And we end up with this list. So these are all the vulnerabilities in the image that controls my home. 517. A lot of them, and especially I want to call out here that none of these CVEs is related to the Home Assistant code itself, so to the application that's actually running on top of this. All of these are coming either from Python modules, from Go modules, or what you can see from the Alpine APK repositories, right? So where somebody does an APK add, adds another application that's needed to actually run it, right? And it's quite a lot. And everyone who does proper CVE scanning during their pipelines, like your pipeline would not allow you usually to ship such an image into production where you have 60 critical CVEs in there, right? It would just stop, somebody has to take care, somebody has to remediate this, and this, of course, costs time. With that, I thought, cool, I'm working for Chainguard, great company. They do have open source stuff available. Maybe I should use this as the base and port all of my application over to Chainguard. With that, I want to introduce you to Wolfi. Anybody ever heard of Wolfi? At least a few, thank you. So Wolfi is Chainguard's Linux undistro. It's a cloud-native operating system, which is being used as the very basis for every Chainguard container that's pretty much out there. We're maintaining the OS ourselves, which means as soon as there are vulnerabilities in the OS, we don't need to wait for somebody else to patch it. We can patch it right away. It's also built completely minimal in what we're calling the Chainguard factory. Right? In the Chainguard factory, and this is one of the welcome to the 2 marketing slides I have, by the way. In the Chainguard factory, we are rebuilding our container images pretty much on a daily basis. We're taking care of version dependency bumping, which allows us to be ahead of the CVE curve. Because usually if a CVE is found in an older version, oftentimes there's already a newer patch release, but that's not yet implemented in other container images because they're not rebuilt that frequently. The Chainguard factory is a very, very huge automation pipeline at the very end of the day, and last week we actually crossed the 1 billion container builds in our factory. And we're building everything directly from the source code. So, which means that whatever image we're building, we're not relying on pre-built artifacts. We're rebuilding everything from the source code, which cuts out a lot of the recent software supply chain attacks, where a maintainer leaked a credential, somebody else uploaded a malicious binary, uploaded malicious packages. This is something that cannot happen with us. And we have bots that are looking for hundreds of thousands upstream repositories, and whenever there's a new release cut, they're going to build a new package, and we're building every container from the ground up. We're building every container in a way so that it only has that included what's needed to run the application. We're currently doing this for 2,500 open source projects, and for over 1,000 of them, we're also creating FIPS images, which only have FIPS validated crypto in there. One of the outcomes of this Chainguard factory is Wolfi, right? So the very bare bones Wolfi base OS container image. If you want to get Wolfi, it's relatively easy. You just do a Docker pull. You don't need to register, just pull Wolfi, and off you go. You can build on top of it. And this is essentially what I'm going to do next. I'm going to migrate all of my Home Assistant application to Wolfi, and then we do the comparison if it actually helped or if it's still at the 500-something CVE mark. Right. So first of all, let's pull Wolfi. I already did this before because Wi-Fi is great. Right, cool. We have Wolfi. Let's, first of all, do the comparison. We did a CVE scan on Alpine, which had only a few CVEs. Now we're doing the CVE scan on Wolfi, and we see that currently Wolfi has 0 CVEs, right? It's super slim. It doesn't have much in there. It's just 15 packages, 27 executables, so not really much. Next up, I want to migrate my application over to Wolfi. For that, I have used the official Docker file that's available in the Home Assistant repository, and I tweaked a few things to actually make it work, and I'm going to run you through it, then we're going to build it, we're going to do a grab scan, and then you can play around with it later on. Right, first of all, obviously, what we need to change is the base image, right? As said, they do have this build from argument over here, which points to their golden image. I'm just going for Wolfi, which means as Wolfi is bare bones, I have to actually run some APK ads here. Interesting thing, Wolfi also uses APK as the package manager, but it points to the Chainguard APK repositories, and it only uses APK because our company founders used to work on Alpine in their past. Right? So the APKs you're actually going to get from the Chainguard repositories, they're also frequently rebuilt, and they're not the same as the ones that Alpine itself uses. I explicitly disregarded this line here, which is a Go binary for video streaming, and that has a lot of CVEs in there. I don't want them. I don't need them. And then, yeah, it's just some Python things where I need to build, actually, because the wheels are not there. And the entry point needs to be adjusted. So not really a hell of a lot I'm doing here. Right, so let's rebuild Home Assistant on Wolfi. This should build from cache, hopefully. Yes, it does, because it took 10 minutes thanks to the Wi-Fi earlier on. Okay, cool. And now I have actually built a container. So we saw the build is working. The question is if it's also running. Before we check if it's able to run, we're actually going to check how many vulnerabilities I'm having now in this container image. Anybody wants to take a guess now? Okay, so 0 is wrong, 500 is wrong as well. We're somewhere in between. Well, Chainguard images are not always coming with 0 CVEs, right? We're trying to, but they're not always. We started with 0, but we're going to install some things on top. So we're going to end up with, I don't have the number in my head, but it's quite a few less. It is? Okay, it is 2 highs for medium. So 6 in total, which means we just by migrating to a different base, using different APK repositories to pull our dependencies in, we have remediated roughly 500 something 90% of our CVEs, right? So now, most probably a pipeline would flag it because it still has highs in there, but only 2, so it depends on the gates. But it would be allowed to ship to production, right? That was the build process. So the build is working. Now we actually need to also check that the application is working, because even the build works doesn't mean the application works. So let's stop the running instance that I'm having right here and restart it with the very same configuration, with the very same arguments, just pointing to my Wolfi image. We will see right away it should work. It looks pretty much the same, right? We have green log output. And if I'm going over here, just to prove that it's still working, like my light is still toggling. Cool? Perfect. Right, so we've done this. We have a light that's blinking, which brings me to the third prize I'm allowed to give away. So whoever of you guys in this beautiful audience is able to make this light blink can come up to us and grab a prize. Scan this QR code, log in with CNS Munich. I'm going to leave the setup running for the rest of the day until the first person comes and finds the correct light switch. Oh. Raiko, can you log in? Just to verify it's working? Perfect. Right. So with that, I actually want to, guys, also tell you how you... Do you need the QR code? Oh, I'm not sure why. I'm super sorry. I didn't do anything. All right. You can have the QR code later if you want to. All right. With that, maybe the other 50% now have understood, hopefully, why CVE checking during pipeline and in general can make sense. You should take care about it. And so I want to... Who was that? Who was that so quickly? What's the UUID? Yeah, that sounds good. Shit. That was way 1,000. And there's also a randomizer who toggles them automatically, so wow. Not bad. Okay, stop it. Please. Right, so that brings me to essentially, if you're interested in hardened container-based images, how you can get started. So we already saw that you can get Wolfi completely for free, but Chainguard also offers another 50-something container images completely for free. You don't need to register. You will only get the latest tag though, which means if you need version tags, this is probably not the way to go. What we're also offering, if you need version tags, you can sign up for what we're calling the Chainguard starter catalog, which gives you access to 5 images of your choice with all the version tags. Only caveat, you need to fill out a form and talk to us. And with that, I'm, well, way faster than I thought I would be. That was it. I'm open for any questions. Happy to have a chat at the booth later on. Thanks for joining. Oh yeah, we still have 6 CVEs. We still do. Where was it? It's, I guess, in this one. Yes, we still have 6 CVEs. And whoa, why is it typing? Ah, cool. Yeah, I just want to show you that the image is much smaller as well. So the 6 CVEs that are in this image, you can see that they're not fixed. They're not fixed yet upstream. We as Chainguard, we don't fix CVEs ourselves usually, right? We rely on upstream fixes. What we're doing is we're rebuilding the container images with all the dependencies much quicker, which brings us ahead of the CVE curve. But if there are unfixed CVEs, as you can see here, they're still there, right? Easy as that. There's another question. That's pretty much true, yes. Yeah, I could pin the latest to the SHA of the specific Wolfi version that's available right away. But yeah, you're right, it's not reproducible, but that was not my intention today. Yes, please. Sorry again, please. That's a very good question. I may think about it, but I'm not a software developer, so there's probably something that I did wrong, but it's working. I'm not sure who's next.
How do you deal with version mismatching between package dependencies? Because when you build from source, if they have their dependencies also something like latest, so whenever you build, it will change. It might change.
You mean how we in Chainguard are doing the version bumping of the dependencies?
The source code, you build from source. So even if you have the same release version, the official one versus you built, they might split differently.
No.
You have different package versions when you install them during the build.
So when we build from source, we actually get the same functional result as the upstream project has. When we're rebuilding things from source, maybe libraries, packages, whatever, we also have the same testing in our factory that the upstream project uses. So obviously it might be that if you look for the hash of the artifact, that is the very outcome. Functionality-wise, it's the same and it's tested the same and it's only shipped if functionality is there. Also, if we see, which also brings me back why we see CVEs in some images, if we see that a version bump or a patch release may break functionality, we're not doing it, right? Which means there might be images where there's a fix available, but it breaks the container functionality, so it's not going to be bumped then. Not sure if this answers the question.
You rely on the test basically of the upstream.
Yes, doing the same testing.
We can take last question.
Last question. Oh, that was the question. That was the question here as well. No, I did not create a pull request, and I so far, honestly, only used it in testing, not in my real prod. Because if you're aware how Home Assistant works, you need to rewrite the supervisor, technically, I think, to point to a different image. And also, they are smart enough to see that you're running on an unsupported third-party container. Completely honest, I tested it, it works, but I'm not using it day in, day out because I'm running it at home. It's hopefully safe enough, and it was just an example. So.